Hello, welcome once again. We're going to be discussing an alternator. I made a few videos about an alternator, the output. From this schematic, as you see over here, actually this is for a Ford, and they're all similar. We have a computer involved. Now, it used to be when the regulator was internal and it kept the voltage constant. Now the computer over here called the PCM, abbreviated, which stands for the Powertrain Control Module, which is the main computer module controlling the current of this alternator and also the voltage regulator. Now, before we get to that, the simple schematic, as you can see, we have the computer over here. We have the ignition switch over here. We have the internal of the AC. This is what's internally in the AC. The casing of it, the metal part of it, the outside of it is the ground, used as the ground. We have these diodes inside that converts. This is an AC generator. The alternator technically is an AC generator. It creates AC signals, three-phase out of each other. But we convert them to DC. Why do we need DC? The battery, as you see over here, which is the red one, the positive one, needs DC. Also, this is always higher voltage than the battery. If the battery, let's say, once you crank it, how much is the voltage of the battery? It could go down to about 10.6, 10.5, normal, right? Well, how much is this? This is around 13 volts to 14 volts. It's always higher than what you are charging. You cannot charge on the same level. If this is 12 volts, you're not going to charge with 12 volts from an alternator. This has to be a higher voltage than this. So, the computer has control. This is the computer. Instead of the PCM that I just showed you, this will be the PCM. The PCM will control something called the rotors and stators over here. Now, it's a winding, it's a rotor that turns, that produces more current. Based upon load conditions, the more accessories you have on, motors, pumps, lights, you will need more current. But also, you have to have the voltage regulated, meaning it can always stay constant. We don't want the voltage fluctuating as we put more accessories on. You put the lights on and it'll go from 12 volts then to 13 volts or 14 volts. No, we want the voltage that's called regulation. Like a power supply has a percentage of regulation. We want the regulator, we want this voltage to be constant. If it's 14 volts, let it be 14 volts. If it's 13.6, let it be 13.6. That's one of the technicalities of these things. So you see, this goes back to these rotors. These are symbols for rotors that turn to create the current over here. Now, the battery output, which is always that thick wire, the red one, this is the battery output. Where does it come from? It comes from the diodes, which just rectify the AC. This is a picture of the stator and the rotors. This is rectified, meaning it is changed to DC. Now the 14 volts comes from here, or 13, whatever it is, comes from this one. Going back to the battery, and also going back to replenish, going to the starting ignition switch, going to replenish or keep the accessories going, the fuel injectors, ignition control module, because after all, not only are you replenishing, is the word, the battery, you still have to keep the accessories going, you still have to keep spark, fuel, and other things going to the engine. Because now you just drained the whole battery when you took away about 200, 300 amps upon startup, upon cranking. So with that in mind, let's go to this one. Now, as we said before, the PCM, which I just showed before, this is the PCM. Now, we want to know the load. We want to know this has to have some input, the computer, to understand the accessories, what's going on. It has to know the battery voltage. This is the battery voltage of over here of the battery condition. After all, we just cranked it, correct? We cranked it. It was 12.6 volts if it's fully charged. It went down to 10.6. Well, the computer has to know this is 10.6. How much do I have to keep on the rotor and the stator? How much do I have to activate them to get the proper voltage and to get the proper current to the accessories? Everything is powered and controlled by the computer. He's getting information, and he's giving the information, controlling what we just said, the rotor, called rotor field current, to give the current. When I made a video one time and I showed you, and I said, what way can I measure the B plus? That's easy. You can always put your voltmeter. Let's say this is the voltmeter that we use, and I use this in the video. This is a clamp meter. This measures current without breaking the path or the wire. You've seen it that I used it before. You wrap it around the wire. That's why I showed you in that video, alternator, I can measure the voltage. Fine. That's step one. To measure the voltage, make sure the voltage is constant, regulated. When you put the blower motor on, when you put the lights on, power windows, everything, whatever you do, it has to be constant. That's the voltmeter. Fine. But the advantage of these meters is a wraparound. I put it around the wire, as I showed you. So refer to that video, because I don't want to make the video so many times doing the same thing. The red wire of the generator, as you'll see when I did it, we find this wire that goes back to, first let's understand the circuit. Upon startup, what happens? We have to feed the starter motor with high current. Wherever you see these wires, thick wires, red wire is a thick wire that carries all that current to the starter motor, 200 amp, 300, whatever it needs, depending upon cylinder, displacement, compression, all these configurations. Anyway, that's that wire. Fine. So let's say you'll take 200 amps over here. It's a thick wire. What can I do? If this is that wire corresponding to this wire, as you see, and I did it in that video, what do? You wrap it around. You take this and you wrap it around. Obviously, with the camera, you take it around and you wrap it around over here. This wire will be in here like this, tucked in like this. This creates a magnetic field. Any current going through a wire creates a magnetic field. This can read the current from that wire without breaking this wire off from the battery. That's a great feature. I can read how many current, how many amps this is drawing, the starter motor is drawing. Great. I can also measure the voltage. Now, before looking otherwise also, we have this battery. Once we crank that engine, alternator takes over, like we just explained. About 13.6 to 14 volts, 14.2 volts. If it's colder, it'll be higher. In these smart systems, might have 16 volts of voltage. We have to go back and feed the battery. Where's the path for the battery? Another thick red wire. Now, since this is a Ford, we have two options. We could go this way or this way, depending upon the model that you have. Let's say we go this way. So current now flows from the alternator, which is what? DC now. How did we get DC? It was rectified from AC. Controlled over here, goes over here. Let's say it takes this path, goes through a fusible link, which is which are wires connected together to melt at a certain temperature. It goes through here. It goes right back to the battery. However, we're not done with that yet. This battery was feeding in the beginning all the accessories. It was feeding the fuel injectors, feeding the ignition control module to make sure you get spark and fuel going to the fuel injectors to turn them on and off. First, you have to turn those things on in order to make the engine crank. So first, this battery did it. He did the job. Once he was drained, the alternator says, okay, my turn now. Now I have to take over. I have to take care of the battery. I have to take care. See, this is a splice. It's connected. I have to take care of the accessories also now because the battery's too weak. So we have one thick wire going back from the alternator to where? To here. Another thick wire going from where? From the battery to the starter motor. Another thick wire going from here to the fuse panel. Why, now, you're going to say, why do we need a thick wire going from here to here? It's, as you see, what is this? This is only 15 amps. Why do I need such a thick wire? In the schematic, what's missing, this fuse panel has other fuses and other systems that this wire goes to. This feeds the main terminal, and then it is branched off or divided off of many, many more fuses and systems that you don't see in this schematic. This only gives you this because this fuse is related to the alternator. However, like I said, much more systems, ignition control module, fuel injectors are connected also here, but it's not in this diagram because we're not discussing computers or fuel injectors. We're discussing alternator. Therefore, you're only going to see the fuse that's associated with the alternator. But by no means, don't think this is the only thing that's being fed. No. No. This is a thick wire. It gives all the current in the beginning to feed all the systems. Until who? Until he takes over. He feeds the battery, then he feeds also the systems. Okay? That's the important part. Now, relating to things like that, like I said, please go watch that video, how to test alternators. What I did was I put it on current. You see this current? As you'll see. Okay. Like I showed you before, you see A right here, amps, DC amps. You zero it. Make sure you're at 0. See, 0, 0. Now, how much you gonna measure, and where am I gonna measure? At the start, I like to measure, which I did over here. I want to see. Since this is computer regulated, the computer regulates it. We're not talking about internal regulator. PCM is the regulator. He's the boss. When I put the accessories on, as you see in that video, and I have this wrapped around this wire, the current will increase. That's a good sign. That means that the computer is realizing that I'm putting more accessories on. The demand is higher for the loads. He's going to react to that until this one over here increase the current of the rotor field current, they call it, like we just spoke about. Let's say to here, 1, 2, 3, three pins over here on a connector, plus the big one, B plus. So this is like the monitoring, and this is like the control over here, or the communications over here to this one. This is the one that he senses how much the battery voltage is, because at the beginning, you're going to go from 12 to about 10.5 or something like that, right? So, again, he's going to control it. Let's say I put, again, the blower motor, which takes about 20 amps or 25 amps at full high speed. He's going to detect it. He's going to detect that load and tell me, you know what, you have to increase the rotor field current to increase to match it. And you see that when I put this meter, I measure current on it. That's why I'm stressing this point over and over again. What's the best way to figure out the computer? You could put a scope over there. If I put a scope over there, it'll be too technical, and I think it'll be a little too technical for the viewers. So I find this method to be a little more simpler. This is about $50, $60, even less today, to buy such a meter. You wrap it around this wire. This wire will be represented by this wire. You wrap it around like I do over there, and you'll see how much current you are pulling. The current should be increasing as you put more accessories on. That tells you the computer is listening to you. He's obeying you, and he's telling him, hey, do your job, increase the current. And how do I know the current was increased? The meter tells me that, because I'm measuring it. Let's say I take off the lights. I take off the fan blower. What should happen to the current? The current should go down, as you see in the video. It could go up to 30 amps, and it could go down to 15 amps. What does that represent me when it goes down? That tells me he sensed the loads, which is the accessories. I turned off the lights, turned off the blower motor. He senses that and tells him, you know what? I need less current. How do I know I have less current? I measure it. If it went from 30 amps to 15 amps, he did his job. He did his job. He's good. They're both good. That's the way I find to measure this thing from computers. Again, you have a fusible link over here. If this fusible link opens up, for whatever reason, this battery is not going to get the charge. Your charge system is going to fail, because from here to here, this is the wire that feeds back the battery. So instead of 14 volts, 13, you could be at 12 volts, you could be at 11 volts, whatever the state of that battery was. Very important. One last thing. Why I picked this type with the small jaw. This can fit into very cramped locations. This is the one that I had. This is more current. However, look at these jaws. It is hard to fit in these very narrow, cramped places in automotive. This is good for electrical. For electrical wiring, 220 and things like that, where you do electrical work. Not always good for automotive. But, again, this current can only go up to 200 amps, as you see, DC. We need more from that when we crank the engine. This will go up to much more. This could go up to about 400 amps or more, and that's what you need. But like I said, this has its pluses and minuses. This has its pluses and minuses. This is good that it has a small jaw. I can fit into very small places, but the current is only up to 200 amps. This I cannot fit into everywhere, but the current is much higher, so I can measure the cranking current over here. This is the cranking current. I could put this one over here to measure the 300 amps that I need or whatever to start it. Then I know it's starting. Pluses and minuses, please go to that video, how to test alternators. You'll see exactly what I'm referring to. Exactly. And always zero the meter before. Anyway, please go to my channel, Joe Electronic Schematics for Auto. If you leave a like. I didn't go over everything because I want you to go over the video. The hands-on, then you'll understand exactly what I'm talking about. That's why I left out some things about the battery light and all these things, but you'll see. So anyway, Automotive Electronic Schematics by Joseph is another one. Please subscribe to that one, and please try to help me out with the advertisement, to watch some of the advertisements, so because I'm monetized for that. Thanks for watching.